Example 9. Simplify each expression. So if we look at the expression in part A, we have the sine of 158.2 degrees over 1 plus the cosine of 158.2 degrees. So we need to turn this into an equivalent expression. We just so happen to be working on half angle identities, so we probably need to use a half angle identity, but keep in mind that if you're on a quiz or an exam, everything's going to be mixed up, so you're going to have to go through your formula list and figure out what exactly this matches up to. Okay, so I know, like I said, we're in the half angle formula section, so we're going to go back to our half angles and we're just going to try to match it up with one of these guys. Okay, so looking at what we have sine over 1 plus cosine, and the arguments are the same. Okay, so sine over 1 plus cosine. So let's go back and take a look. Where do we see sine over 1 plus cosine? That's right here, sine over 1 plus cosine. Okay, so this is a half angle formula for the tangent of a over 2. Okay, so I'm going to go back to our work and write down this identity, okay, and then we will use it to simplify the expression. Okay, so we know that the tangent of a over 2 is equal to the sine of a over 1 plus the cosine of a. All right, so we have the expression we've been given. It matches the right side of this identity, okay? So we really need to be comparing what we've been given to the right side. Okay, so if I write them side by side, I've got sine a over 1 plus the cosine of a. Okay, so again, we see the sine matching and we see the 1 plus cosine matching. Okay, so what does that tell us? That tells us that the a value, the argument a, has to be equal to 158.2 degrees. Okay, so we know the a value. Okay, so if we're working this thing backwards, okay, again, let me write it out here. We started with the sine of 158.2 degrees over 1 plus the cosine of 158.2 degrees, okay? So we know this matches up, if we go backwards, if we use the identity this way, that sine over 1 plus cosine business matches up to the tangent of a over 2. Okay, but we said that our a value is 158.2 degrees, so we need to divide it by 2. Okay, so this is a number, so we can go to our calculator and we can punch in 158.2 divided by 2, and we're going to get 79.1 degrees. Okay, so this is going to give us the tangent of 79.1 degrees. Okay, this is the answer. Okay, this is an expression that is equivalent to the original. Yes, you can go to your calculator and you can get a numerical number here. You can get like a decimal, but don't bother. We're looking for an equivalent expression. We don't want a messy decimal as the answer. You can, however, check yourself. You can plug in the original expression and get the decimal expansion and then compare it to the decimal expansion of tangent of 79.1 degrees. And I'll do that here. I'm in radian mode. I need to change over to degrees. Always check yourself when you can. Okay, so if we look at this, let's punch in the numerator, which is the sine of 158.2 degrees, and then we need to divide that by the entire denominator, so put parentheses if you need to. If you have an older calculator, you're probably going to have to. So this is going to be 1 plus the cosine of 158.2 degrees. Okay, close the parentheses on the denominator. Here's my decimal expansion, and then I'll do the tangent of 79.1 degrees, and they match. Okay, so I know that I have simplified correctly. Okay, moving on to the expression in part B, we are given plus or minus the square root of 1 minus the cosine of 3 theta over 5 all over 2. Okay, so again, you may be given this on a quiz or an exam, and you're told to simplify this. You're just going to have to match it up with one of the identities, whether it be half angle or some indifference formulas or product to sum. You have to look through the whole list, okay? So we know we're in half angle. It's probably a half angle, okay? It definitely resembles some of the crazy half angle formulas because we see that plus or minus in the square root. So it is going to be half angle. So we need to go to our half angle list. Of course, we need to look at the three that have the plus or minus the square root of, but we need to look underneath the square root. We need to see 1 minus the cosine over 2. Okay, so if I go back to my list, okay, I'm looking for 1 minus cosine over 2. Okay, 1 minus cosine over 2. That's going to be this one. Okay, so if you translate it backwards, this is a formula for the sine of a over 2. Okay, so I'm going to go back to my work here and I'm going to write this identity down. Okay, we know that the sine of a over 2 is equal to plus or minus the square root of 1 minus the cosine of a over 2. Okay, so now we have to basically, if you look at this, we obviously have been given a match to the right side of this identity. So I'm going to line them up. Okay, we were given plus or minus the square root of 1 minus the cosine of 3 theta over 5 all over 2. We need to match that up to the right side, plus or minus the square root of 1 minus the cosine of a over 2. Okay, so I know the square root and the plus or minus matches, those guys match, and then I see the 1 minus cosine matching, I see the 2 matching. So when I look at this in comparison, I see that the a value here has to be 3 theta over 5. Okay, so now I can use this red identity backwards. Okay, so I know that plus or minus the square root of 1 minus the cosine of 3 theta over 5 all over 2. Okay, we're going to use the identity backwards. Okay, we have an exact match to our red identity with a being 3 theta over 5. Okay, so this is going to be equal to the sine of a, which is 3 theta over 5, but that angle has to be divided by 2. Okay, so this is going to be the sine of, we've got 3 theta over 5, which is a fraction. We are dividing by 2, which is the same as multiplying by 1/2. Okay, so the answer here, the final answer, this is going to be the sine of 3 theta over 10. Okay, unfortunately, we can't check this one because we have a variable. Okay, but this is telling us that what we started with, okay, this original expression plus or minus the square root of 1 minus the cosine of 3 theta over 5 all over 2 is the same as the simpler expression, the sine of 3 theta over 10. Okay, moving on to example 10. Okay, this is going to be a very quick example. Determine whether the positive or negative square root should be selected. Okay, so what I have in both parts A and B is an equation. It's already written out for you. It's basically like, okay, so in part A, I want to calculate the cosine of 58 degrees, and here's how you do it by using a half angle formula. Okay, you're not checking the validity here. Everything is a true statement. Okay, the whole point of the question is, if you were looking at calculating this trigonometric function and you're using the half angle identity to do that, would you pick the plus or minus? Because remember, you can't have both. Okay, the cosine of 58 degrees can't be both negative or positive. Okay, so let's talk about this. Like I said, this is a quick example. Okay, so to calculate the cosine of 58 degrees, you would use the half angle formula, or you could use, I should say, the half angle formula for cosine. Okay, so obviously 116 divided by 2 is going to give you the 58. Okay, do we choose the plus or the minus? Remember what I told you at the very beginning. At the end of the day, you are calculating the cosine of 58 degrees. Okay, so that's the angle you need to look at. Well, we know that 58 degrees is between 0 and 90 degrees, and so it's in quadrant 1. Okay, so in quadrant 1, the cosine is positive. So choose positive. Okay, so that's the answer. If we used this expression on the right to calculate the cosine of 58 degrees, we should choose the positive version. Okay, let's look at the one in part B. We are calculating the tangent of 95 degrees, and here you would be applying a half angle formula for tangent. Out of the 3 tangent equations, you'd obviously be applying the more complicated one. 190 degrees divided by 2 gives you the 95. So again, we could calculate this and that would give us the tangent of 95 degrees. We just have to figure out if we need to choose the plus or minus. At the end of the day, we are figuring out the tangent of 95 degrees, so we don't need to bother with the 190 here. Okay, so when we think about 95 degrees, it is just over 90 degrees. So that means 95 degrees is between 90 degrees and 180 degrees. So it's in quadrant 2. In quadrant 2, tangent is negative. So you should choose the negative sign. And that's it. That's all this question was asking. If I am calculating these values and I'm applying a half angle formula, should I choose the plus or minus? Again, one more time, at the end of the day, it all comes down to the trigonometric function that you are calculating. You're going by that angle and which quadrant it lies in.